In this lab report, we had to investigate what free fall is. It is the descent of a body in which the gravitational force is the only force acting over the object. Our hypothesis is that depending on the height where the ball is located above the ground and the resistance of the air, it will take more or less time to reach the floor where the starting point from the time it is released. Our hypothesis is related to free fall because Galileo's law of free fall states that in the absence of air resistance, all bodies fall with the same acceleration, independent of their mass. In our daily life, it's important to know about this phenomenon because it is necessary for us to know how things work around us. Free fall is completely related to sciences because it explains velocity, distance, resistance, acceleration of the Earth, which is gravity, and how it affects the object.
For many years, it was thought that the idea proposed by the Greek philosopher Aristotle, who argued that heavy objects fall faster than lighter bodies, was the whole truth. Almost 2 centuries later, the Italian scientist Galileo Galilei challenged this idea and said that the bodies, both light and heavy, fall at the same time. Galileo climbed to the top of the Tower of Pisa to live simultaneously dropping 2 major areas, one of wood and another one of lead. But no one believed in him. In 1642, the Irish scientist Robert Boyle confirmed this result by dropping a lead ball and a pen in a glass container, which was extracted air. With this experiment, Boyle showed us that the force that reduces the speed of the body in the fall is air resistance. Galileo was right.
So, to calculate the time that Sarai took to react, we're going to use the S formula and we're going to substitute. We're going to use 0.25 meters, that is 25 centimeters, and the initial velocity, which is 0, and it's cancelled with the time. Then 1/2 times the gravity, which is 9.8, and then our time that we don't know it. And then we're gonna isolate 0.25 1/2 the gravity equals times square. Then the square we're gonna use it in a root. Root 0.25 over 1/2 times 9.8 equals, and the time is 0.22 seconds.
The gravitational force is a force that attracts any object with mass. Every object, including you, is pulled on every other object in the entire universe. This is called Newton's universal law of gravitation. Galileo dropped two balls with different masses from the top of the Leaning Tower of Pisa. He demonstrated that all objects fall at the same time, independent of their masses. However, if we did the same thing in the North Pole, in the equator, in Australia, or any other part of the Earth, the time will be a little different because gravity is not the same in all the Earth.
Conclusion. We came to the conclusion that after making all the process and analyzing all the results, we realized that when you throw an object as a free fall, the two most important factors that determine the time are the air and the form. Observing and analyzing this makes state our hypothesis was right. We understood that an object that is free falling, the acceleration is equal in all the time and that this does not depend on weight of the object.